Hello everyone. They say that until and unless you spread your wings, you don't know how far you can fly. Well, that's very obvious because we know that life is not about uh, finding yourself, it's about creating yourself. So please make sure that you create yourself by knowing your potential to the fullest, right? We are in the midst of discussing the chapter called Force. This is the second of the series, and in this lecture, we are going to talk about the effects of force. Let's begin the session. A force cannot be seen. A force can be judged only by the effects it can produce in various objects around us. A force can produce five effects, namely, it can move a stationary object, it can stop a moving object, a force can change the speed of a moving object, it can also change the direction of a moving object, and a force can change the shape or size of an object. Let us take a rubber ball and place it on a tabletop. When we gently push the ball along the surface of the table, we'll observe that the ball begins to move. Thus, a ball at rest or a stationary ball begins to move when a force or push is applied to it. While taking penalty kick in a football match, the player applies a force on the stationary ball. Before being hit, the football is at rest and its speed is zero. The force applied by the player makes the football move towards the goal. Thus, if we kick a stationary football kept on the ground, then the football starts moving. In this case, the force of our foot makes the stationary football move. Similarly, the force of engine makes a stationary car to move. From these examples, we conclude that a force can move a stationary object. When we take a rubber ball and place it on the table and give it a gentle push, we find that the ball starts rolling. Now, if we place our palm in front of the moving ball, we would observe that the moving ball comes to a stop. Actually, the palm held in the path of the moving rubber ball applies a force to the moving ball. This stops the moving ball. Thus, a moving ball stops when a force is applied to it. In a football match, when the goalkeeper dives or jumps to save the goal, he applies a force to the moving ball with his hands. This force applied by the goalkeeper helps in stopping the moving football and saves a goal being scored. Thus, the stopping of a moving ball by a goalkeeper demonstrates that a force can stop a moving object. From all these examples, we can conclude that a force can stop a moving object. Let us suppose that we are moving on a bicycle at a certain speed. Now, if someone pushes the moving bicycle from behind, then the speed of bicycle increases and it will start moving faster. On the other hand, if someone pulls the moving bicycle from behind, then the speed of bicycle decreases and it will move slower. Thus, a push or pull can change the speed of a moving bicycle. But a push or pull is called force. So we can say that a force can change the speed of moving bicycle, or for that reason any other moving object. If the force is applied in the direction of motion of the object, its speed increases. On the other hand, if the force is applied in the direction opposite to the direction of motion of an object, then its speed decreases. When a ball is dropped from a height, its speed goes on increasing. The speed of a falling object like a ball increases because the earth applies a pulling force on it, which is called the force of gravity. It is the force of gravity of the earth which pulls a falling object towards its center and increases its speed. On the other hand, when a ball is thrown upward, then its speed goes on decreasing. This is because the earth applies a pulling force of gravity on the ball in the downward direction, which is opposite to the motion of the ball. When a hockey player hits a moving ball, the speed of the ball increases. When we pedal the bicycle faster, then the speed of the bicycle increases. And when we apply the brakes to the moving bicycle, then the speed of the bicycle decreases. From all these examples, we can conclude that a force can change the speed of a moving object. In a cricket match, when a moving cricket ball is hit by a bat, then the direction of cricket ball changes and it goes in another direction. In this case, the force exerted by bat changes the direction of a moving cricket ball. In the game of carom, when we take a rebound, then the direction of striker changes. This is because the edge of the carom board exerts a force on the striker. From these examples, we can conclude that a force can change the direction of motion of a moving object. Before we go any further, let us explore the meaning of the term state of motion. Well, the state of motion of an object is described by its speed and the direction of motion. A change in either the speed of an object or the direction of its motion or both is called a change in its state of motion. A force can change the state of motion of an object. If we take a light spring and pull it at both the ends with our hands, then the shape and size of the spring changes. In this case, the force of our hands changes the shape and size of the spring. The turns of the spring becomes further apart and its length increases. Here are some examples in which a force changes the shape or size of an object. The shape of draw needed weight flow changes on pressing with a rolling pin. A rolling pin is basically a balan to make chapatis. When we press the draw with a rolling pin, we apply force. So we can say that the shape of draw changes on applying force. The shape of kneaded weight clay changes when a potter converts it into pots of different shapes and sizes. This happens because the potter applies force on the kneaded weight clay. The shape of a toothpaste tube or an ointment tube for that reason changes when we squeeze it because we apply force while squeezing it. When we hammer a piece of aluminium metal, its shape changes and an aluminium sheet is formed. This change in shape occurs because we apply force while hammering. Similarly, the shape of a sponge, tomato, balloon, or tennis ball changes on pressing, and the shape and size of a rubber band changes on stretching. The shape and size of a balloon changes when it is filled with air or water because the weight of air or water exerts force on the walls of the balloon from inside. From these various examples, we can conclude that a force can change the shape and size of an object. What we are going to do right now is we have just learned about the effects of force, and here we are going to just do a recapitulation of whatever we have learned. And how we are going to do that? We are going to do that with the help of a mind map. Mind map actually helps us to recall things in a faster way. When you get stuck in the exam hall, this mind map is going to come handy. Let's see how to go about this. If you see force being the central theme, and we have the effects of force as one of its branches. Over here, if you see, one of the effect has been mentioned is can move the stationary object, isn't it? This is one thing that we have talked about. We have said with the force we can move a body which is stationary. The second effect is it can stop a moving object. If a body is moving, we can stop by the application of force. Example could be the application of brakes for a car. The third branch, it talks about can change the speed of a moving object. Yes, this is again something which we have learned, that by the application of force we can change the speed of an object. Either we can increase or decrease the speed. It can change the direction of the moving object. Yes. By the application of force, if we wish to turn around a circle, we can turn around that easily with the application of force. Take the example of the steering that I have shared in the lecture. We can also have the size and shape being changed because of what? Because of application of force. So over here, what we have done, we have whatever the 5 effects of force we have talked about, we have jotted it down so that it gets into our system and we can recall it easily during the exam. Thank you. This brings us to the end of lecture. Still, in case you have queries, please do feel free to write to me at sanyal.shankha@gmail.com. And by now, I believe you all are aware that where you need to send your worksheets. Thank you so much.